Hello everybody, it's Amel, and today I'm going to teach you how to solve the walls and gates problem. You are given an m by n 2D grid initialized with these three possible values. -1, a wall or an obstacle. 0, a gate. INF, infinity, means an empty room. Fill each empty room with a distance to its nearest gate. If it is impossible to reach a room, that room should remain filled with INF. So as an example, this is the input, this is the 2D grid, and 0 represents a gate, -1 represents a wall or an obstacle, and INF are the empty rooms. So as you can see, this is the output, and you start from the gates and you move to the empty rooms, and the distance to the nearest gate is 1, so you see a 1 here. Then when you continue moving downward, you see that this empty room, the closest gate, is a distance 2, this is a distance 3, so you fill those empty rooms with a distance to the closest gate. If there is an obstacle, you cannot pass. For example, here there's an obstacle to the left, so as you are traversing, you cannot go this way. And for instance here, the closest gate is a distance 4. 1, 2, 3, and 4. So how can we solve this problem? We can solve this problem in two ways, using depth first search or breadth first search. So if we use depth first search, we use recursion, so we use the stack implicitly, and we can start traversing from the gates, and we can have a variable, the distance, that we can increment every time that we move to the left, up, down, or to the right. And if we find an obstacle, then we return. If we find another gate, we also return. If we find an empty room, that means that we were able to reach an empty room, so we modify the empty room to have the distance to the nearest gate. So without further ado, I'm going to show you how to write the code using depth first search. The code using breadth first search is using a queue and iteration, but in this video I'll show you depth first search. So first, I'm going to have to iterate through the input matrix. So for integer I, case of value 0, I is less than rooms.length plus I. For integer j, case of value 0, j is less than rooms, so by that length plus j. Then for every point ij in the matrix, for every position ij in the matrix, I will check if it is a gate. If it is a gate, I want to start the traversal using depth first search. So a gate is represented by 0. So if rooms sub I sub j equals 0, this is a gate, so I will do a DFS from this gate. I will pass the rooms matrix, position I, position j, and the distance is a variable initialized to 0 first. And as I move in all directions, I increment the distance. So now this is the main body. So I will have my helper method, the DFS method, that uses recursion. So private void depth first search is gonna take a two-dimensional array of integer, the rooms, position I, position j, and integer distance. So first, I want to have my base case. As I'm traversing the matrix, I need to check if I'm out of bounds. If I'm out of bounds, I need to return. Also, if this is an obstacle, I need to return. If this is a gate, I also need to return, because I don't want to modify the gates. I don't want to modify the obstacles either, and I don't want to go past the obstacles. So I have to check that in the base case. So first, if I is less than 0, or I is greater than or equal to rooms.length, or j is less than 0, or j is greater than or equal to rooms sub I that length, or rooms sub I sub j is less than the distance that I have so far, then I just return back. So as I said, if I'm out of bounds, these conditions check. If I'm out of bounds, I have to return back because I'm out of the grid. Also, if I see that the value at position ij in the matrix is less than the distance that I have, that means that this is either an obstacle or a gate. This is either a wall or a gate. For example, I start at this gate, for example, and then the distance is 0. When I move down here, the distance is 1. If I try to move here, this is a wall. So the value here is less than the distance, which is 1. In this case, the distance will be 2 already. So -1 is less than 2. So I know that this is an obstacle. This is a wall. So I have to return 2. I have to return back. Also, for instance, I move down here, distance is 1. To the left, distance is 2. To the left, distance is 3. Down, distance is 4. Then I move here, distance is 5. And then I see that this is a gate. And 0 is less than 5. So because 0 is less than 5, I know that this is actually a gate, and I don't want to modify the gate either. So I return back. So these are my base cases. Then if I get down here, that means that this is an empty room, which is represented by INF, infinity. So I can actually modify the value there to be the distance to the closest gate. So rooms sub I sub j gets the value of the distance. And then I just need to do DFS in all 4 directions. Up, down, left, and right. So DFS rooms going up is I-1 j, and I have to increment the distance by 1, as I told you before when I was doing the examples here. I also do DFS rooms going down, that would be I+1 j, distance plus 1. Then DFS rooms, I have to go to the left, that would be j-1, distance plus 1. And DFS rooms I j+1, distance plus 1. So this is going to the right. Going up, going down, going to the left, and going to the right. So this is the exploration using depth first search, which uses the stack implicitly. So now I'm going to run the code. Alright, this is working perfectly. If you like this video, please press the like button. Don't forget to subscribe, and see you next time.